important things. So the first term that we are supposed to learn about when you talk about laws of motion is what is inertia. Inertia. Inertia becomes a very important thing. So when you talk about inertia, inertia is nothing but inertia is nothing but inertia is the object's tendency to oppose its change of state. Basically, an object does not want to change its state. Basically, if I want to talk in terms of humans, laziness. You are very lazy, right? You don't want to get up, you don't want to play, you don't want to study, and if you are playing, you want to keep playing, you don't want to come, so you don't want to change your state. Whatever you are doing, you want to keep doing that. So that is called as inertia. You are resisting the change, so that is called as inertia. So inertia, when you talk about an object generally, whenever you talk about an object, it's inertia. What is inertia? How do you measure inertia? So inertia is nothing but the mass of the object. Mass of object. If the mass of the object is very high, that means its inertia will be high. Because a heavy object, it's very hard to move an heavy object, and it's very hard to stop a moving object as well. Correct? So it's hard to move or it's hard to stop. Both are hard. So that's why it is called as inertia. Now when you talk about Newton, see, inertia is directly proportional to mass. So if I want to write here, I can write inertia is nothing but mass. It directly depends on the mass of the object. Now let's talk about the Newton's laws. Newton gave various laws, right? So let's talk about the Newton's laws. So the Newton's first law of motion. Newton's laws. So Newton's first law. When you talk about what is Newton's first law, Newton's first law talks about its law of inertia. Newton's first law is only law of inertia. An object which is moving wants to stay in motion. An object which is at rest wants to stay at rest, unless and until an external force is applied to it. So basically, unless you apply an external force to the object is going to stay in the same state it is in. For example, you have seen objects in bus. Bus is an example. If you go in a bus, you have observed it. When the bus driver suddenly applies brake, you fall towards the front because you don't want to change your state. You are moving along with the bus. When the bus is moving, when the bus is moving forward, along with the bus moving forward, you are also moving forward in the bus. Correct? You are also moving forward indirectly because the bus is moving forward, the bus is taking you also forward. As soon as the bus applies brake, you don't want to change the state. Somehow the brakes stop the bus, the brakes stop the wheels of the bus, but there's no one to stop you. That's why you fall on the front. But when the same thing happens, when you are at rest, suppose the bus is at rest, suppose the bus is at rest, and you are also at rest right now, both are stopping, both are stationary. Now the bus suddenly moves, but there's no one to move you. That's why you keep standing at the same place and the bus moves forward. That's why you tend to fall backward. So that is nothing but Newton's first law. Or you can take a glass example. Suppose you have a glass. Suppose I have a glass. On top of the glass, if I keep a piece of paper, on top of a glass, I kept a piece of paper, and this piece of paper has a coin on top of it. This piece of paper has a coin on top of it. Suddenly, if I flick this paper, if I hit this paper suddenly, the paper will fly off and the coin will fall inside. The paper will fly off and the coin will fall inside. Why? Because the coin wants to stay at the same place, but the paper comes out. So this is nothing but Newton's first law. It is called as Newton's law of inertia. When you talk about the second law of Newton, second law talks about force basically. So Newton's second law tells us that force acting on an object is directly proportional to the momentum. Now what is momentum? Change in momentum or rate of change of momentum. Force applied on an object is directly proportional to the rate of change of momentum. See, triangle in physics means change. When an object is changing, we write it with a triangle. So difference between final minus initial, final momentum minus initial momentum, that is called as. So momentum is also same. Momentum is also similar. So how easy it is to stop an object, a moving object? Who is going to tell you that? That is going to be told by momentum. Whether it's easy or hard to stop an object, that is being told by momentum. That is being told by momentum. So mass, if the mass of the object is very high, it has more momentum. If a truck is coming towards you with the same speed, or if a cycle is coming towards you with the same speed, which is easier to stop? Obviously it's easy to stop a cycle, right, from your hand, because the cycle's mass is less. So momentum depends on mass, the mass of the cycle. It tells us about the momentum. The momentum of the cycle is less, so it's easy to stop a cycle. But suppose the same cycle is coming with very high velocity, whereas the truck is coming with just 2 meter per second, then it's easy to stop a truck. You can push this truck and stop it, but the cycle is coming with 100 meter per second. It will cut you into pieces and go like a bullet. It's coming. Then it's very hard to stop a cycle because the velocity of the cycle is very high. That increases the momentum of the cycle. So momentum is nothing but mass into velocity. Now what happens? Force, from here if you see, force will be equal to change in mass into velocity divided by change in time. From here if you see, generally the mass doesn't change. So the mass is constant. It is going to be outside. Only the velocity changes generally. So change in velocity over change in time, and the mass comes outside. And this change in velocity over change in time is also known as acceleration. You learned in the previous chapter. So that's why the formula for force is mass into acceleration. Now tell me, when does this formula apply? This formula is applicable only when the mass is constant. Remember, this is where people get confused. If the mass is constant, if you see rockets, in the rockets the mass also is changing. When the rocket is flying upward, when the rocket, when this rocket is flying upward, when the rocket is flying upward, what is happening? The fuel is getting burnt, and because of that the mass of the rocket is decreasing. And then can you use this formula, mass into acceleration? No, you cannot use this formula, mass into acceleration, because the mass is not constant, and here we assume that the mass generally remains constant. So in real life, when mass of the objects is constant, then you can use this formula, force is equal to ma. But if the mass of the object is changing, then you are supposed to use this formula, or you can use differentiation. Force will be, see, wherever there is change, you can also write differentiation. Force is equal to differentiation of momentum by, with respect to time. This is the formula for this is what Newton's second law tells us. Now what does Newton's third law tells us? Newton's third law is very famous. Newton's third law tells us that every action, Newton's third law, as all of you know, every action has equal and opposite reaction. So basically, if you push the floor behind, the floor is pushing you forward. That's why you're able to walk. When you swim in the water, you are pushing the water behind, but the water is pushing you forward. So basically, the force what one is putting on two, basically the force what one puts on two, the same force two puts on one in the opposite direction. In the opposite direction, the same force two puts on one. That is the meaning of this. So force that one puts on two is equal to force that two puts on one, just in the opposite direction. So that is what is Newton's third law. Now let's talk about impulse. What is impulse? There is one more thing which is very important, you must know. That is impulse. So now what is impulse? What is this? What is this impulse? Impulse is nothing but when you integrate force with respect to time. When you integrate force with respect to time, means a force acting over a small period. For example, a batsman gave an impulse on the ball. That's why the ball suddenly flies off in the other direction, right? Or you can take, whenever you do integration, you can take area. Okay, so if you have force and time graph, you can take the area under the graph, and this area will give you the impulse. This area will give you the impulse basically. So impulse is nothing but force per unit time, and you know force is nothing but mass into velocity by time into time. If you do, you get mass into mass times velocity. So impulse is nothing but force into change in time. You can use this formula. Next, what is a spring force? How much force does a spring put on an object? So spring force is also known as Hooke's law. Hooke's law states that force exerted by a spring is equal to K, that is spring constant times X, how much you are compressing it from the equilibrium position. From the, if this is the spring, this is its natural position. The spring wants to stay here. From here, if I push it this side 2 meter, this 2 is my X value. Or if I pull it this side by 2 meters, suppose I stretched it this side by 2 meter, then this will be my 2 meter. So whatever you are extending it from the natural length, that is called as X. And this K depends on the medium. K depends on what the medium or what is the material of the spring. Material, size of the spring, or diameter of the spring. So it depends on all those factors. Next, let's talk about the next most important thing, motion of bodies in contact. How is the motion of bodies in? Suppose you have two masses. Suppose you have two masses. This is mass 1 and this is mass 2. You are pushing the mass 1, you are putting force on mass 1, and this side it is getting an acceleration. So the force in such a case will be equal to mass 1 plus mass 2 into acceleration, because both are moving together, both are moving in contact together. So in that case the force is going to be total mass. You are going to take the total mass and multiply with the acceleration. Now what is going to happen if the forces are acting on opposite direction? So this is first case, force acts on a body of mass m. Now let's talk about the second case. In second case, what is happening? M2 is putting force on mass m1. Here both are going in the same direction, but here suppose m2 is putting a force on m1. M2 is putting a force on m1 this side, and m1 is having a force this side. This is going to be my F, and this is my F1. This force is my F1, and body is moving this side with acceleration. So in that case, if you draw the free body diagram, such diagrams what I am drawing in the form of box, this is known as free body diagram. If I draw the free body diagram only of mass 1 and mass 1, this side there is a force F1 acting, and this side there is a force F acting, and the body is going this side. So what you are supposed to do, you are supposed to do F is going to be positive because it's acting in the direction of acceleration, and F1 is in the opposite direction of acceleration, so you write minus sign with that. This is going to be equal to MA. This is the final formula. Force 1 minus force 2 is equal to MA. For body M2, if you want to study for body M2, the action of force on body M2 here will be equal to the action of body F2 will be M2. If you studied about M2 from the same diagram, F1 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 is acting this side and acceleration is acting this side. So in that case, F1 is equal to m2a, or you can write F1 is equal to m2 into f divided by m1 plus m2. This is the formula. Because here if you look here if you look here, F1 will be equal to m1 plus m2. So this is the concept. See here, f m1 plus m2 if you take. See, you can clearly see here, f1 into m1 plus m2 is equal to f m2. This is basically the formula. Now, when you have pulley questions, this is a little important. Pulley questions. Before that, let me talk about friction. There is another type of force which is known as friction. Friction is a force which acts in the opposite direction. Or it is opposing the force. Okay. So whenever you try to move an object, it opposes that. So it is called as friction. So basically, if you talk about friction, friction acts in the opposite direction. If I try to pull an object this side, frictional force is acting behind, that is called as friction. So if an object is moving this side, suppose it is accelerating this side, then the friction is always acting opposite direction. So the frictional force is nothing but frictional force equals mu into n. Remember this formula. This is friction. Friction is equal to mu n. There are two types of friction. One is static friction. When object is stationary, suppose I have a slope like this, object is not sliding below. So who is keeping this stationary? That is static friction. So static friction is equal to mu n, that is mu Sn. This is coefficient of static friction. And force in kinetic friction, suppose the object is moving this side, but somebody is trying to slow it down, that is known as kinetic friction, which is acting when the objects are moving. So coefficient of kinetic friction, this is frictional force. So when there is frictional force, you are supposed to account for that frictional force as well in the opposite direction. So don't worry, when we do questions, we will be able to learn in detail majority of the things. Now let me just talk about the pulleys also a little bit, so that you are able to understand that, and then we'll wind up. So this is pulley. When you have pulley system, frictionless pulley, here if a mass is attached, suppose m1 mass is attached here, and suppose m2 mass is attached here, and tension is acting this side, and tension here, tension will be same. Okay, tension is the like normal force. When object is there on the ground, normal force is acting. When object is hanging, tension is acting upward. Now the objects are accelerating here upward, that means this mass is heavy, right? So object is having acceleration, here acceleration is downward, here acceleration is upward. Okay, so this is the situation, this is the diagram of pulley. Now from here we can see clearly that mass 1 is greater than mass 2. I will change the color. So mass 1 is greater than mass 2, you can clearly see according to the diagram. So for mass 1, if you write for mass 1, m1g is the force, right? Minus tension force is acting upward. If you see here, mass 1, if you focus on the mass 1 here, just look at the mass 1. Mass 1, downward m1g is acting. Downward, completely m1g is acting. Upward, t is acting. So m1g minus t, that is going to be the total force acting on it, and the total force is going to be ma. Total force always we write equal to ma, that is mass 1 into acceleration, whatever total acceleration is. This is how we write it. Okay, so force is equal to both the forces you are going to subtract if they are acting in the opposite direction, and if mass is greater, you subtract the mass equation. Now from here you can clearly write same way. For mass 2, if you write mass 2, it's going to be T minus m2g, because here tension is more. And then if you write here m2a is the force. Now if you try to find the acceleration, acceleration will be equal to m1 minus m2 divided by m1 plus m2 into g. This is the formula. This is going to be the formula. If you see here, if you try to solve the equations and if you try to find the value of m, if you try to find the value of a, basically here a is going to be this much. So how do you get it? Remember it, m1 minus m2 g, net pulling force. See, the formula is net pulling force divided by total mass pulled. Because you know force formula is equal to force is equal to ma, right? So from here if you see, basically this is ma formula only, don't get confused with this. See, total force acting is m1 minus m2g. Here this is the total force because m1 is more, m2 is less. m1 g minus m2g is the total force that you are going to experience this side, because this side there is a force which is pulling upward. So total force is m1 minus m2 into g. And another formula for force is m1 plus m2, because total mass is m1 plus m2 into a. So we have just equated the forces. m1 plus m2 into a is equal to one force, m1 minus m2 g into g is equal to the other force. So that from there if you separate the value of a, you will get this formula. So this formula is nothing different. Okay, now tension, if you try to find tension, tension is going to be 2 m1 m2 divided by m1 plus m2 into g. How did this formula come? We are going to solve these two equations. Okay, so we can subtract or add these two equations and find the value of t from this. You know, two equations. If you try to do that, you will get this formula. So we have just solved these two equations. Okay, you can try that on your own. This is equation 1, this is equation 2. You know, according to your mathematics, you can subtract or add these equations, and then the remaining terms, whatever can get cancelled, will get cancelled out, or you divide these two equations. That's going to be more better. Divide these two equations. So if you divide these two equations, you will see whatever is getting cancelled here, a might be getting cancelled, then whatever is happening, you see. So either you add and see, or divide. No, you cannot divide because division will be hard, I think. You just add the two equations. You're going to get this final equation. So this is going to be 2 times product of m divided by sum of two masses into g. G is also there. Reaction and suspension of pulley. What reaction is going to be experienced here? If you try to see what reaction it is going to be experienced here, this is going to be 2t, because both the side tension is same direction. So here tension will be 2 times of t. So double of this. It's going to be double of this equation. That is reaction at the pulley. That is called reaction at pulley. If you see case 2, this is case 1. If you talk about case 2, questions like this. So in such questions, what is going to happen? See here, mass 1. This is my mass 1, and this is hanging here with pulley. Mass 2. Here there is a pulley, and here see, acceleration is downward here, and tension is going to be present here, and the object is having acceleration like this. Tension is there here like this. Okay, so for example, for mass 1, here also, here if you see, for mass 1, tension is equal to mass 1a. For mass 1, tension is equal to mass 1 into acceleration. For mass 2, if you see, m2 minus m2g minus t is equal to m2a. Here there is no acceleration due to gravity, so directly you can write tension is equal to this one. But here if you write m2g is acting downward, tension is acting upward, so minus t is equal to m2a. So same formula, same method we are going to use. Here if you see the acceleration here is going to be m2g divided by m1 plus m2. We are going to solve these two equations and we are going to find the value of a. Okay, so we can substitute the value of t here. If you try to find the value of t here, t is going to be m1a, right? T is m1a, already we know t is m1a. So here if I write m1a, here if I write m1a, then what do you get? m1a will go that side, it becomes plus m1a, so m2a plus m1a is equal to m2g. You have this equation. Now from here you can find out a into m2 plus m1. If you take n common, m2g. Here if you find the value of a, you are going to get this equation. So like this equation has come. Okay, I just explained you. Same way in the first question also that equation has come. Same way in the first question also that equation had come. Here also same way. By solving these two equations we can find the value of a. That's how the value of acceleration actually comes. And t also same thing. You can substitute the value there and you can find the value of t. T is going to be m1 m2 by m1 plus m2 into g. This is the formula for tension. So this is basic chapter. I have just given it in very short the basic brief of the chapter. Questions we will be seeing. If you people are commenting below, I will definitely take live sessions, because until I have lot of people showing interest, even if one person is commenting on every video, I will definitely focus on that one person, because I don't want 100 people. Honestly speaking, I don't want 100 people, but I want one serious person. So if one of you is also serious, and if I know that you are watching till the end of the videos, all my videos, I will definitely take live sessions for you. And you can definitely join my WhatsApp group by commenting below. I will add you in the WhatsApp groups, and we will you will be given personal attention and personal guidance, the complete 40-day NEET crash course along with materials. Because I definitely feel that education should not be a business, and we want to focus on each one of you, giving you personal attention. So definitely click on the like button and subscribe to the channel.